Hello, today we are talking about triangles again, this time specifically isosceles and equilateral triangles. So if you have forgotten, an isosceles triangle is a triangle with two congruent sides. Once again, congruent just means that they are the same length. So you might think of it as two equal sides, but technically the math word is congruent, but they're the same distance, like this right here in red that I'm doing, and this right here in red. They look the same distance, and these little tick marks right here mean they are the same distance. So that is an an isosceles triangle. Equilateral would just have all three sides congruent. That's the difference. So we're going to be talking about two things here. First of all, the vocabulary. Two congruent sides are called legs. So basically these little tick marks I made, those two sides are going to be called the legs, the two sides that are the same. And if you look across for them, where 2 and 3 are, 2 and 3 are going to be called the base angles. They are across from the legs. If you remember that vocab word, they're across from each other. If here's a leg, the base is across from it. If here's a leg, the base is across from it. It's going to be the two angles that are congruent. That's what I'm about to read out loud to you all on these things. If two sides of a triangle are congruent, then the base angles are congruent. And the converse, if two of the base angles are the same, then the two opposite sides have to be the same. And you know, if you're a visual person, you can probably see that it even looks true. If you just draw two sides that look the same, like those two distances look the same, I just drew them. If I connect them into a triangle, you can see that the angles also look the same. And you can do that with any two distances. I can do like this distance, and then do that same distance again, maybe in this direction or something. And then if you connect the dots, you'll see those angles also once again look the same. It doesn't matter how you orient it. So there you go. This is something we kind of learned already. If you watched my other video on, let's just say you had a 60-degree angle, a 90-degree angle, and a 30-degree angle, something like that. One thing we talked about is that if you have a bigger angle, that means its opposite side is going to be big. So 90 degrees means the biggest opposite side. Since that was the biggest number, its opposite side is also the biggest. Meanwhile, 30 was the smallest. Since 30 is smallest, its opposite side is going to be the smallest. But then what happens if they're the same? So let's just say this is, I don't know, 50, 50, and then 80. Because once again, they do have to make 180 degrees put together. But all of a sudden, these are tied for lowest, right? Tied for lowest. But if there's, I don't know, that's supposed to be an L and an O. But if they're tied for lowest, then that means the opposite sides should also be tied, right? If it's not the lowest, they're tied for lowest, that means the opposite sides have to be tied as well, which is the definition of isosceles. So it all kind of goes together there. If it has tying angles, then the opposite sides also have to be tied, meaning the same. So here we go, some questions. In number 1, it says that angle D is 106, and then C and E are something. Since these two sides are the same, it does mean these two angles have to be the same. So there's two ways to do this. If you are an algebra person, what you'll probably want to do is label these angles x. They are the same x because they have to be the same length, and you can set up the old-fashioned equation. All three angles added together is 180. So x plus 106 equals 180, right? 1, 2, 3. The three angles added together equal 180. but x plus x is 2x. And we're just going to go ahead and solve. That's going to be 74. And if you divide by 2, you get, I think 37. So both angles have to be 37 degrees. And that's just the answer. Now, I'm more of a visual person. If you're also a visual person, then you might want to think about it this way. You know that a triangle is 180, as this calculator does not have batteries. But luckily, I'm a math teacher, so I have a backup. You start with the 180 degrees of a triangle, and then you get rid of this 106. So this is how much is left. But since they are the same, you have to divide it in half, right? Split it into 2 equal parts. So we'll divide it by 2, and we'll get that 37. So either way, you get 37. And it's just a different way of thinking about it. If you notice, if we compare this over here, subtracting 106 was literally what I did here in red. Dividing by 2 is what I did over here in red as well. So you do the same thing. It's just, do you feel like writing it down and solving, or just kind of looking at it? It's up to you. But in number 2, we do have to do an equation. So as I always do with videos, if you think you know what to do, I would just go ahead, pause it, see if you can come up with a plan of attack, and then see if you're right about it. But what we're going to do is, since these two sides are the same, these two angles are the same. And if they're the same, then that means you can literally set them equal to each other. So did you anticipate that's what to do? Hopefully. If not, that's why you're watching the video, right? The next question is, do you know how to solve for x? I always put a line across the equal sign. Let's see, x's. The x's are on opposite sides of the equal, so I'll go ahead and subtract 5x from both sides. Then 8 minus 5 is 3. Then add 30 to both sides. And we'll get 39 is equal to 3x. And then we'll divide by 3 on both sides. And that should be 13. So once again, I do that fast, but you can always rewind and pause as much as you want. There you go, 13. Just make it prettier because that looks like a B. X is 13, it asks for x. If you did need to find the actual angle, you would plug it in. This doesn't ask for it, but if I did plug in 13, you'd get that, which would be the exact same thing as the other one, right? It does say they're supposed to be the same, so you should get the same number in both. So if you just plug it in, 13 for x, right? 5 times 13 plus 9, 8 times 13 minus 30. You get the same thing. And if it asks for that angle, then you would just do the 180 trick to solve for it. But that's the kind of thing that happens on SATs, not in, Virginia SOLs. SATs, you might have to find that angle. Equilateral triangles. In an equilateral triangle, all 3 sides are the same, and all 3 angles are the same. And one implies the other. It uses this if and only if statements that we use in logic. It's called a biconditional. So if all of the angles are the same, right? If the angles are the same, then that means the lengths have to be the same. Or if all of the lengths are the same, then that means the angles have to be the same. There you go. So, in number 3, well, just to go ahead and get it out of the way, if this is 60 and that is 60, we can find the other one by making sure they add up to 180. So, what's the last one going to be? 60. Well, you know, we are kind of talking about equilateral triangles, so it should make sense that all of the angles are the same. I didn't read this part out loud. A triangle is equilateral if and only if it is equiangular. So if all of the angles are the same, then all of the lengths are the same. So all of the angles are 60. So anytime you have an equilateral, all angles equal 60 degrees. Boom. I'll go ahead and like highlight that or something. Boom, boom. All angles are 60 degrees. Oops, sorry, I should zoom out a little bit. Okay. All angles have to equal 60 degrees because 60 plus 60 plus 60 equals 180. And they're all the same. After that, since all of the angles are the same, that means all of the sides have to be the same. Now I am going to zoom in for a little bit because I do want to like rotate this a little bit to explain something. So the two angles that it gave us were this 60 and 60, right? 60 and 60. So if it gave us these two angles are the same, then this is technically an isosceles triangle where these two lengths are the same. But then if you were to shift your paper this way, that 60 is equal to that 60. So this length is the same as that length, which means this is also isosceles. So this length has to be the same thing as that length. And as you can see, I just marked everything. If I felt like it, I could rotate it one more time, and you'd see that the base angles are the same, so the opposite two sides have to be the same. But you're just marking everything as the same. So 60 degrees, 9 feet, 9 feet. Done. For the number 4, there's a long way to do it and a short way to do it. The reason I would still talk about the long way is because if you're a person who just likes a standard thing to do, then there is a way to get this that is standard so you don't have to remember as much. So I'll say the short way first just because we just talked about it, and that is the thing I put in yellow up here. All angles are 60 degrees. So when it tells you that is an equilateral triangle, I can use that fact from over there. All angles are 60 degrees. So I know for a fact that this is 60 degrees, and this is 60 degrees, and this is 60 degrees. So I can immediately set up an equation, 7x minus 3 equals 60. All three angles had to be 60, so I can just set that equal to the 60. Then I'll add 3. And divide by 7. And you get x equals 9, right? So that's if you remember that. If you remember, equilateral means 60 degrees, fill in all 60s, put it there. But let's just say worst case scenario, you completely forget that. If you completely forget about that, then you can say, well, since it is equilateral, all three angles are the same. So forget about the 60 for a second. They're all the same. So if this is 7x minus 3, then this is 7x minus 3, and this is 7x minus 3. So all three of them are 7x minus 3. So what do all three angles add up to? The answer, all three angles have to add to 180. Just like all triangles, all three angles add up to 180. So then if you combine like terms, you get 21x minus 9 equals that. So combine like terms, and then you solve. So add 9 and divide by 21, and guess what? guess what? I just used the one with no batteries again. 189 divided by 21 is 9. Which, you know, is exactly what we got over there. It's the same answer. So it doesn't matter which one you do, it's just what works best for you. The last thing we're doing is solving for y. So here's the thing with y. In an equilateral triangle, all 3 sides are also the same. So I'm going to write down a true statement. A true statement would be 14y minus 59 is equal to 9y plus 1 is equal to 11y minus 23. Those are 3 things that are equal to each other, and that is absolutely true. These are 3 things equal to each other. The thing is, it's not very helpful because in order to solve an equation, you're only supposed to have one equal sign, right? This equals that. This equals that. But this equals that equals that. It's not as useful. So what you do is you just pick 2. It does not matter which 2. I'm just going to go ahead and ignore this part right here. I'm going to ignore that. And I'm just going to work with that part there. So I'll go ahead and I'll solve this equation right there. So y's are on opposite sides, so I'll subtract. Add the 59. And divide by 5, and you get y equals 12. Boom, like that. So you just pick any 2 sides, and you'll get an answer. It does not matter which 2 sides you use. You'll always get the same answer. Just to prove it, I'll do it here. I'll use this one, and then I'll just pick, I don't know, 9y plus 1. So 9y plus 1. So now I'm going to be solving this equation in pink. So to solve this, there's still y's on both sides, so you would subtract 9y. And you'd get 2y minus 23 equals 1. So you add 23. And you get 2y equals 24. So you divide by 2, and 24 divided by 2 is 12. Which, doesn't that look familiar? So it does not matter which 2 sides you use. As long as you use 2, it'll get the same thing. And that is it for these notes. So hopefully it was helpful, and have a great day.